is on polynomial functions and their graphs. Now, so we're going to talk about what is a polynomial function at all, what are some characteristics of polynomial functions, and then we're going to put that all together to be able to draw the graphs. I know you have a graphing calculator, and I know that it will draw you the picture, but the problem when you get to a polynomial graph is sometimes you can't see the whole picture. We call that a complete graph. And so with some of these ideas that I'm going to tell you, it gives you a better idea about whether you've got the whole picture or not, or you need to change your viewing window so you can see more of what's going on to make sure you have the whole picture. So the first thing we want to be able to do is actually just identify it. Is this a polynomial? Okay, so polynomial functions are always of a certain form. F of x is equal to some number, I'm going to call it a sub n. There's going to be a number times a variable raised to a power. We're going to call that power n right now because I don't want to put a number in there. Okay? And then, if they're in the correct descending order, then the next power is one less. And this term is just another constant. And it goes all the way down to a constant term, where the power on the exponent is going down by 1 every time. Now the thing that makes it a polynomial is that n, and all the subsequent n's, where as it goes down by 1, has to be an integer. N is a non-negative, so it can't be negative either. So it can't be like the square root of x. That's not an integral exponent. It has to be like x to the first power, x to the second power, x to the third power, x to the fourth power. It's got to be just an integer. Y'all know what an integer is, right? And it can be like -2 or -4 for it to be a polynomial. Now, we can have those things, but they're not considered polynomials. We've already talked about some polynomial functions. We've got the one where it's f of x is equal to just some number, right? That was a constant function. Y'all remember that one? That's y equals a number. You know, it's a horizontal line. And then we have the ones where it's f of x is equal to some number times x to the first power, right? If you don't have an exponent, x is automatically to the first power. This was called what? If x is to the first power, it's called what? Linear. And what's an equation that's in this form called? Quadratic. Okay, those are the ones we've worked with. In this section, we're going to be talking about polynomial functions that have a power of 3 or higher. Now, when we talk about this stuff, we do need to look at, here my formula, this term right here, which is the term that's got the highest exponent in it, is called my leading term. My leading term tells me the degree, because the degree of the entire polynomial is the degree of the highest term. So the degree of this particular polynomial is n. And it comes out of the term that's got the highest power. And it ought to be at the beginning if you've got it in descending order like you're supposed to. And then this A sub n is called the leading coefficient. And there are a lot of things that we can tell about this particular function if we can look at the leading coefficient. Okay, so those are the things that you're going to be looking at when you look at this, is you're looking for the leading term because it tells you the degree of the polynomial, and the number that's attached to that is the leading coefficient, and it tells me a whole bunch of information about the look of the graph. These polynomial functions, their main characteristics: that they have smooth, continuous graphs. Okay, continuous does not mean that it goes on forever, right? We're not talking about continuous as in English, we're talking about continuous as in math. Can anybody remind me of what the word continuous means from mathematics? Has no break in it. Has no break in it. So in other words, as I'm walking along, there's never going to be a hole or an asymptote or anything else that we've talked about in this graph, right? There's no ending point. It's just a nice, smooth, continuous curve with no gaps. So, first thing, or the third thing that we want to talk about here is the end behavior. But this is our first application of that information that I was telling you that we needed from this leading term. Okay, so when we look at the end behavior of the graph, now everybody know what end behavior means? What does end mean? At the end of something. Okay, so in other words, if I'm looking at a polynomial graph, then I'm talking about what's happening out here, not in the middle, out here on the ends, way out here as I get to a negative infinity and a positive infinity, what's going on. Okay? Everybody understand? Doesn't apply to the middle, just applies that at the end. The end behavior is based solely on the leading term. So when we get a polynomial and we look at this, we are just looking at that leading term. I like to organize it this way. On the leading term, or the degree of the polynomial, remember we called that n a while ago. N was the degree of the polynomial, right? That's the exponent. If n is an odd number, everybody knows what odd numbers are, right? 3, 5, 7, okay? And a sub n, which is the leading term, right, the number in front, is a number that's greater than 0. What does that mean to us? It's positive, right? It's a positive number. So the leading term's positive. Then what happens here, I'm just going to draw a piece of a graph here, is that these graphs are always going to start down or fall to the left. They're going to do some turns here in the middle, but they're going to end up shooting off into a positive infinity. Okay? So the author's way in this book of notating that is he does this. Falls to the left, rises to the right. That's his little shorthand for that. Okay? Everybody understand that? If n is odd, but a sub n is less than 0, so it's a negative number, then it does the opposite thing. It's going to start up. It's going to do some turnaround stuff here in the middle, nice smooth curves. We don't know what it's doing, but it is going to wind up falling to the right. So it starts up, ends falling down. It rises to the left and falls to the right. Okay? Now, the degree doesn't have to be odd. It can be even, right? So if a sub n is greater than 0, then what happens is it starts up, does some stuff in the middle, and it finishes up. Okay? Got it? And if it's, yep, starts down, does some stuff in the middle, ends down. So checkpoint 1. They want us to determine the end behavior of f of x equal to x to the 4th minus 4x squared. Determine the end behavior. Remember, I look at just the leading term. So which one's the leading term? X to the 4th. The exponent, that's what I look at first, is that an odd or an even number? It's even. So the degree is even. And it's the number in front of x, which happens to be no number up there. So what is it? Positive 1. So it's a number that is greater than 0. So that means that it's going to start up and finish up. Or the way the author writes it is he says it rises to the left and rises to the right. That's all there is to it. On the test, I have seen this. Okay. The little arrows help you come up with this answer. Because if the arrow's pointing up, it's rising, and if it's on the left side, it's rising to the left. You know what I'm saying? I personally would do